all to Think Maths. This is Class 10 Maths, Chapter 9, Some Applications of Trigonometry. In this session, we are going to discuss about Exercise 9.1, question numbers 6 to 10. In the previous video, we discussed about questions from 1 to 5. Its link is given in the description. You can check the link. So, question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree. As he walks towards the building, find the distance he walked towards the building. Okay. Now we have to draw the diagram. So in trigonometry, we will take only the right angle triangle. So what is given in the first line? It is 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So this boy is 1.5 meter tall. So this distance AB is the boy. So AB is the boy. So it is 1.5 meter. So this line is just parallel. So this line will also be 1.5 meter. So standing at some distance from a 30 meter tall building. So CD. So CD is the building. So CD is 30 meter. So this whole distance is 30 meter. So CD is the building. It is 30 meter. So the angle of elevation from his eyes to the top of the building. So this boy is standing here. So angle of elevation from the eyes. So it starts from here to the top of the building increases from 30 degree to 60 degree. So these are the details given. Find the distance he walked towards the building. Now let us take this point as E. So this boy is walking this distance towards the building. So this is towards the building. So the building is here. CD is the building. The boy is walking towards the building and he stops at E. At this point, the angle of elevation is 60 degree. We have to find the distance he walked towards the building. So we have to find AE. Okay. Now, what is this point? Let us take this point as F. Okay, children. Now, AF and BD will be same distance. Also, we should know the distance of CF. What is CF? CF is nothing but total distance CD minus FD. So, these are the things we get from this question. From this, we have to find out AE. Now, let us start the solution. Let AB be the boy and CD be the building. Next, what are the values given? AB is equal to 1.5 meter. Next, CD. CD building height is 30 meter. So, it is 30 meter. Then what will be CF? So, CF is equal to total distance CD minus FD. What will be FD? Both AB and FD are same. So, FD will also be 1.5 meter. So, CF equal to CD is 30 minus 1.5. What is 30 minus 1.5? 30 can be written as 30.0 minus 1.5. So, 0 minus 5 not possible. So, from 3 we take, this will become 9 and this will become 10. So, 10 minus 5 is 5. 9 minus 1 is 8. Put that decimal here. 2. 2 minus 0, 2. So, it is 28.5 meter. So, CF equal to 28.5 meter. Next, what is given? Angle of elevation. So, angle of elevation. So, what are the angle of elevation given? Angle CAF. Angle CAF equal to 30 degree and angle CEF. As he moves towards the building, angle of elevation becomes 60 degree. So, CEF EF equal to 60 degree. What we need to find? We need to find AE. Okay, children? So let us take this triangle. This is the right angle triangle. We can take the triangle. First we can take the bigger triangle CAF. So from right triangle CAF. So here which is the opposite side? 30 degree opposite is this. This is 90 degree. F makes 90 degree. So this is hypotenuse and this is the adjacent side. So what are all the values we know? We know CF, that is opposite we know. What we have to find? We have to find out this AE. So AE is in adjacent side. So the relation is between opposite and adjacent. So sine matches for O by H. So sine is for opposite by hypotenuse and cos. C is for cos. Cos is for adjacent by hypotenuse. And T is for tan. So T is for opposite by adjacent. So just to take the first word from some old hippie caught another hippie tripping on acid. So take the first letter. S is for sine, O is for opposite, H is for hypotenuse. C is for cos, A is for adjacent, H is for hypotenuse. T is for tan, O is for opposite and A is for adjacent. So O by A matches for tan. So we will take the tan. So what is the angle of elevation for triangle CAF? 30 degree. So tan 30 degree equal to opposite by adjacent. So which is the opposite side? CF. So CF by adjacent side is AF. What is tan 30? Tan 30 is 1 by root 3. 1 by root 3 equal to CF. What is CF? CF is 28.5. So 28.5 divided by AF. Now we have to cross multiply. 1 into AF is AF equal to root 3 into 28.5. So 28.5 root 3 meter. So we know AF. This whole line is known. Now if we get AF, we cannot take the triangle ACE as it is not right angle. So we will take the triangle CEF to find EF. So if we find EF from AF, if we subtract EF, we will get AE. So we will find EF in the next page. So from previous page, we have AF equal to 28.5 root 3. So we found this full line length. Now we have to, from the right angle triangle CEF, we have to find out EF. So if we find EF from AF, if we subtract EF, we will get AE. Okay. So we are going to use the right angle triangle from right triangle CEF. CEF. So in this triangle, angle CEF equal to 60 degree. So which side is here? In this also we have opposite side is known and we have to find out from the adjacent side. So tan matches for opposite and adjacent. So tan 60 degree equal to opposite by adjacent. So which is the opposite side? This CF. So CF, adjacent side is EF. Tan 60 is root 3. So we will get root 3 is equal to, what is CF? CF is 28.5. 28.5 divided by EF. So just cross multiply. So if you cross multiply, root 3 into EF equal to 1 into 28.5, which is 28.5. So EF will be equal to 28.5 divided by. So root 3 is in product. When we change the sign, it will come to division. So EF equal to 28.5 by root 3 meter. Now what we have to find? The distance he walked towards the building. So distance the boy walked towards the building. What is the distance he walked? From the point A, he walked towards E. So AE. AE is nothing but total distance AF. From that, if we subtract EF, we will get AE. So what is AF? AF is 28.5 root 3. 28.5 root 3 minus EF is 28.5 divided by root 3. 28.5 divided by root 3. Now if we take root 3 as LCM, here in this, in division, there is no root 3. So multiply and divide by root 3. So we will get 28.5 root 3 into root 3 is 3 minus 28.5, which is equal to, here 28.5 is common. Take that outside. The remaining will be 3 minus 1 divided by root 3. So 28.5, 3 minus 1 is 2. In denominator we have root. To take that root outside, we will multiply and divide by root 3. So we will get 28.5 into 2 into root 3 divided by 3, which is equal to 1 3s are 3, 7 3s are 21. So we will get 9. 9 3s are 27. So it is decimal here. Put the decimal. 28 minus 27 is balance 1. So 50. So it is 5. So 9.5 into 2. What is 9.5 into 2? 5 2s are 10. Let us do the calculation here. 9.5 into 2. So we will get 5 2s are 10. Balance 1. Decimal point here. 9 2s are 18. 18 plus 1. 19. So it is 19.0, which is equal to 19. So 19 root 3 meter. So the distance the boy walked towards the building is 19 root 3 meter. Okay children, I hope you can understand this problem. So moving on to the next problem in the next page. Seventh one. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree. Find the height of the tower. So we have to draw the diagram. What is that? From a point on the ground. So let me draw this roughly. From a point on the ground. So there is a point, another point here. The angle of elevation of the bottom and the top of a transmission tower. Where is the transmission tower? Fixed at the top of a 20-meter high building. So there is a high building here. Its height is 20 meters. The tower is fixed on this top of this building. So this is the tower. So AB is the tower and BC is the building. Okay. So AB is the tower and BC is the building. What is given here? The angle of elevation of the bottom and the top. Bottom and the top. From where? From the point on the ground. Point on the ground is here. So it's angle of elevation. So we have to draw a horizontal line here. Angle of elevation. For angle of elevation, the horizontal line will be below. So the horizontal line is here. Angle of elevation here. So what is given? The angle of elevation of the bottom and the top are 45 degree and 60 degree. So first bottom is for 45. So bottom of a transmission tower is at B. So this is 45 degree and 60 degree. So top is 60 degree. So this angle makes 60 degree. Okay children. So in this way you have to draw the diagram. So let me mark it here. So let us take, let AB be the building. So AB is the building. So building height is 20 meter. So building height is 20 meter. From the top of the building, a tower. So let me mark it as C. So AC is the tower. So from top and bottom, angle of elevation is made with the horizontal line. So this is a point on the ground. So from a point on the ground, the angle of elevation of the bottom. So AC is the tower, A is the bottom of the tower. Bottom of the tower is fixed at the top of a building. So A is the bottom of the tower and A is the top of the building. So from bottom of the tower to the ground. A ground, it has a point D. So its angle is 45 degree. And the top of a transmission tower from a point on the ground. So from a point on the ground to the top of a transmission tower, its angle is 60 degree. So these are the things given. What they are asking, find the height of the tower, which is the tower AC. So we have to find out AC. So let me start the solution. Let AB be the building and AC be the transmission tower. What is given? 20 meter. AB is equal to 20 meter. This is given. Then angle of elevation. What are angle of elevation given? From the bottom and top. So from the bottom it is ADB. Angle ADB equal to 45 degree. From the top of the tower it is C. Angle CDB equal to 60 degree. These are the things given. We have to find out AC. AC is the height of the tower. So we have to find out AC. Now where is AC? So this AC is on opposite side. So opposite side, which value is given? Opposite side value is given. So to find AC, we should know BC. So if we know BC, then BC minus AB is nothing but AC. So AC is nothing but BC, total length BC minus AB. So which is equal to BC minus AB is 20. So to find BC, where is BC here? This is the whole opposite side. So to find BC, we have to know any one of these side. So we can find out DB. DB is common for both the triangles. For triangle ADB as well as for triangle CDB, DB is common. So if we find DB from this small triangle, because we can find DB, because this opposite side AB is known and angle of elevation is known. From triangle ADB, we can find DB. So if we find DB from the I'm sorry, from the bigger triangle, we can find BC. So if we find BC, if we substitute here, we will get the value of AC. Here AC, I'm sorry, not AB, AC. Okay. So let me start the solution. So from right triangle ADB. From right triangle ADB. So opposite side is known. So this opposite side, angle opposite, this is 90 degree and this is hypotenuse. 90 degree opposite is hypotenuse and DB is the adjacent side. We are going to find out the adjacent side, which is common for both the small triangle and big triangle. So we are going to find the adjacent side. The relation is between opposite and adjacent. So opposite and adjacent matches for tan. So the angle is 45. So tan 45 degree equal to opposite side. Who is the opposite side? AB. AB by who is the adjacent side? DB. Tan 45 is 1. So 1 is equal to AB is 20. So 20 divided by DB. Just cross multiply. So 1 into dB is dB. 1 into 20 is 20. So dB is equal to 20 meter. Next we are going to use the big triangle CDB. So from right triangle CDB. So here also the relation is between opposite. We are going to find BC. So if we find BC, we can substitute here and find out the height of the tower. So to find BC, we have to know DB. So as we found DB from the right triangle CDB, we can find out BC. So DB is in adjacent side, BC is in opposite side. So tan matches for this and the angle is 60 degree. So tan 60 degree equal to opposite side. Opposite side is full length BC. BC divided by adjacent side is DB. What is tan 60? Tan 60 is 1 by root 3. Not 1 by root 3, I'm sorry. Root 3. Tan 60 is root 3. So root 3 is equal to BC. We doesn't know BC by what is DB? DB is 20. So just cross multiply. 1 into BC is BC equal to root 3 into 20. So we can write it as 20 root 3. So BC is equal to 20 root 3 meter. What we have to find out? Height of the tower. What is height of the tower? Height of the tower is nothing but AC. So height of the tower is AC. AC is equal to BC minus 20. What is BC? BC is 20 root 3 minus 20. So we can take 20 as common. So the remaining will be root 3 minus 1 meter. So height of the tower equal to 20 root 3 minus 1 meter. So I hope you can understand this problem. So moving on to the next problem in the next page. So eighth problem, a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. So first let us draw the diagram roughly. Now what is given? A statue is there and pedestal is there. So where is the statue? Statue stands on top of a pedestal. So this is the pedestal and on top of the pedestal a statue stands. So let AB be the statue and BC be the pedestal. So this is pedestal and this is statue. So its height is 1.6 meter. 1.6 meter from a point on the ground. Let us take a point D on the ground. From a point on the ground, the angle of elevation of the top of the statue. AB is the statue, its top is A. So from a point on the ground, the angle of elevation. So angle of elevation makes with the horizontal line. So horizontal line will be below the angle of elevation. So it is 60 degree. So this is over and from the same point, which is the same point D. From the same point, the angle of elevation of the top of the pedestal. So BC is the pedestal, its top is B. So its angle of elevation with the horizontal line is 45 degree. What we have to find? We have to find out the height of the pedestal. We have to find BC length. We know only AB length. This is same as the previous problem. In the previous problem, this lower part is known. We found the upper part. So here upper part is known. We have to find out the lower part. So which is the common side for both the triangle? DC is the common side. So we have to find out the common side. So if we find out the common side, we can apply in the small triangle to find BC. Okay, children. So let us find out this and copy this here. So let me take, this is A, B, C. So AB is the statue. Its value is 1.6. BC is the pedestal. We have to find. So D is a point on the ground. So what is given? Let AB be the statue BC. BC be the pedestal. Next, what is given? Statue height. Statue height is 1.6 meter. So, AB is equal to 1.6 meter from a point on the ground. So, D be the point on the ground. From a point on the ground, the angle of elevation of the top of the statue. So AB is the statue, its top is A. So angle ADC. ADC is 60 degree. So angle of elevation, angle ADC equal to 60 degree. Another value, and from the same point. So same point is D. From the same point, the angle of elevation of the top of a pedestal. BC is the pedestal, its top is B. So its angle of elevation with the horizontal line is 45 degree. So angle BDC equal to 45 degree. So which is known here? Angle opposite. So this is the opposite side and this is 90 degree. 90 degree opposite is hypotenuse and the remaining is the adjacent side. We know some value in opposite side. So opposite side in some value is known, which is the common side DC. So DC is in adjacent. So the relationship is between opposite and adjacent. Okay, children. So we are going to use the tan relation. So let us first take the bigger triangle because we have to find out BC. So we have to know AC. So from the bigger triangle, let us form a relation between AC and DC. So just listen. We have to take triangle from triangle ADC. So it is between opposite and adjacent. So tan matches, its angle is 60 degree. So tan 60 equal to opposite by adjacent. What is tan 60? Tan 60 is root 3. Which is the opposite side in the bigger triangle? AC. So AC by adjacent side is DC. AC by DC. So root 3 equal to AC can be written as AB plus BC. AB plus BC divided by DC. So the reason is AC equal to AB plus BC. So root 3, what is AB? AB is 1.6. 1.6 plus BC divided by DC. Now cross multiply. So root 3 into DC equal to 1 into, so 1 into doesn't change. So 1.6 plus BC. So we have an equation between DC and BC. So mark this as 1. Now take the smaller triangle BDC. So from triangle BDC. So this is also relation between opposite and adjacent. So tan, what is the angle here? 45 degree. So tan 45 degree equal to opposite side is BC. So in the small triangle, opposite side is BC. BC by adjacent side is DC. What is tan 45? Tan 45 is 1. So 1 is equal to BC by DC. So just cross multiply. We will get 1 into DC equal to BC. So this is the second equation. So what we can do from 1 and 2, we can substitute instead of DC, we can substitute BC. So from 1 and 2. What we get instead of DC, we are going to substitute BC. So root 3 BC equal to 1.6 plus BC. So taking this BC to left hand side, root 3 BC plus BC will become minus BC equal to 1.6. Next one, we have to take BC outside. So if we take BC outside, it will be root 3 minus 1. If we take root 3, if we take BC outside, the remaining will be root 3 minus 1 equal to 1.6. So BC will be equal to 1.6 divided by, this is in product. So it will come to division on the other side, root 3 minus 1. So next we have to take the conjugate. We will do that in the next page. So from previous page we have BC is equal to 1.6 divided by root 3 minus 1. So here we have root 3 minus 1. In order to avoid root 3 in the denominator, we are going to multiply by the conjugate. So what do you mean by conjugate? It is nothing but if it is A minus B, its conjugate is A plus B. So we have to multiply and divide by root 3 plus 1 on numerator as well as in denominator. So we have in the numerator 1.6 into root 3 plus 1. In the denominator, it is A minus B into A plus B. What is A minus B into A plus B? Yes, you are all very smart. You know that it is A square minus B square. A plus B into A minus B is A square minus B square. So here A is root 3. So it means root 3 square minus B square. B square is 1. So 1 square. So we have 1.6 into root 3 plus 1. What is root 3 square? Root 3 square is nothing but root 3 into root 3. So we have root of 3 into 3. If in square root the number appears twice, the answer is that number. So answer is 3. So root 3 square is 3 minus 1 square is 1. So 3 minus 1 it is 2. So 1.6 into root 3 plus 1 divided by 2. So if we divide 1.6 by 2, so how do you divide 1.6 divided by 2? So this one is not divisible. So put 1 0 and a decimal is here. So if we take 16, decimal is here. So put the decimal. So it is 2 8s are 16. So it is 0. Okay. So the answer is 0.8 into root 3 plus 1. So what is BC? BC is nothing but pedestal. Find the height of the pedestal. So we have to write the solution as height of the pedestal equal to 0.8 into root 3 plus 1 meter. Okay, children? I hope you can understand this problem. So moving on to the next problem, ninth one. The angle of elevation of the top of a building from the foot of the tower is 30 degree. And the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. Here there are two things, tower and building. Okay, so tower will be higher, taller, and building will be smaller. So this is building and this is the tower. What is given? The angle of elevation of the top of a building. So from the top of a building, the angle of elevation of the top of a building from the foot of the tower. So from the foot to the top. So this angle of elevation makes with the horizontal line down. So this is the angle of elevation. It is 30 degree. And the angle of elevation of the top of the tower. So this is the tower. Top of the tower from the foot of the building. The building foot is here. From the foot of the building to the top of the tower, angle of elevation is 60 degree. If the tower is 50 meter, so this height is 50 meter, we have to find out the height of the building. Okay, children? So this is the way you have to draw the diagram. So let me copy it here. So let us take AB as the building and CD as the tower. So AB we need to find the height of the building. So we have to find out the height of the building. height of the tower is 50 meter. So this is 50 meter. The angle of elevation of the top of a building from the foot of the tower. Foot of the tower is 30 degree and angle of elevation of the top of the tower from foot of the building is 60 degree. Okay. So these are the things marked. Let me start the solution. So let AB be the building and CD be the tower. What is given? Tower height is 50 meter. That is CD is equal to 50 meter. What we have to find? We have to find out AB. What is angle of elevation given? Angle of elevation. There are two angles given. Angle ADB. Angle ADB is equal to 30 degree. Then angle CBD. Angle CBD equal to 60 degree. These are the things given. We have to find out AB. So here for both the triangles BD. This is the common one. BD is common. Okay. So if we find from one triangle BD, we can apply it for another triangle. So we have to find AB. AB is in the triangle ABD. Here only angle is known, no other side is known. So from this bigger triangle, if we find BD, we can use this for the smaller triangle. So in the bigger triangle, this is known. One side is known, another side we have to find. So here this is 90 degree. Angle D is 90 degree. For triangle CBD. This angle D is 90 degree and this is 60 degree. CD is 50 meter. So opposite side, 60 degree opposite. This is the opposite side. D. D makes 90 degree. Its opposite is hypotenuse and BD is the adjacent side. We are going to use the common side BD. We have to find out the common side BD. Here opposite side is no. So opposite and adjacent makes the relation for tan. So it is tan 60 degree. So we write from triangle CBD tan 60 degree equal to opposite by adjacent. What is tan 60? Root 3. Opposite side is CD. Adjacent side is BD. So root 3 equal to CD value is 50. 50 divided by BD. What is the next step? Just we have to cross multiply. So root 3 into BD. Root 3 into BD equal to 50. So next BD. BD will be equal to 50. Root 3 is in product. When we change the side, it will come to division. So BD is equal to 50 by root 3 meter. Now we are going to use this in the triangle ABD. So from triangle ABD. We know BD, we have to find out AB. So let me draw this triangle here. So D, A, B. So angle D is 30 degree. 30 degree opposite. Adjacent side is A. Angle B is 90 degree. B opposite is hypotenuse. So we know A. A is not A, that is adjacent side. Adjacent side is BD. BD is 50 by root 3, which we found here. Now 50 by root 3 is known. We have to find out the opposite side. Again it matches for opposite and adjacent. So that makes tan. So tan 30 degree equal to opposite by adjacent side. What is tan 30? 1 by root 3. Opposite side is AB and adjacent side is BD. So 1 by root 3 equal to AB. We have to find out what is BD. BD is 50 by root 3. So 1 by root 3 AB. So if there is a division under the denominator, so we can put it as multiplication and just write the reciprocal. So if there is a division in the denominator, if you take that to the numerator, it will reciprocate. So it will be root 3 by 50. 50 by root 3 will become root 3 by 50. So this means 1 by root 3 equal to AB root 3 divided by 50. Now cross multiply. So root 3 into AB root 3. So AB is here. AB into root 3, another root 3 equal to 50. So cross multiplying here, AB is here, root 3, another root 3. So AB into root 3 equal to 1 into 50 is 50. So AB into root 3 into root 3 is, so if in square root, the number appears twice, the answer is that number equal to 50. So AB is equal to 50 by 3. 3 is in product, it will come to division on the other side. So if the numerator is the bigger number, just divide and write it as mixed fraction. So 1 3s are 3, balance 2, is 6 3s are 18. So 20 minus 18 is 2 divided by 3. So 3 comes here. So just here I will do that here. 50 divided by 3. So 1 3s are 3. 5 minus 3 is 2. 20. So 6 3s are 18. 20 minus 18 is 2. To write it as mixed fraction, quotient and remainder divided by divisor. So 16 2 by 3 is the answer. So 16 2 by 3 meter. So what is AB? AB is the height of the building. So height of the building equal to 16 2 by 3 meter. So to write the solution, you can write it as height of the building. Height of the building is AB. AB is equal to 16 2 by 3 meter. Okay, children. So if the numerator is bigger than the denominator, you can write it as mixed fraction. So 16 2 by 3 meter is the answer. So moving on to the 10th question in the next page. So this is the last question for this session. Two poles of equal heights are standing opposite to each other on either side of the road, which is 80-meter wide. From a point between them on the road, the angles of elevation of the top of the poles are 60° and 30° respectively. Find the height of the poles and the distance of the point from the poles. So here what is given? Two poles of equal heights. So let me take the two poles as AB and CD. Here AB and CD are poles. So let us write, let AB and CD be the poles. They are given that equal heights. So that means AB equal to CD. Both are equal heights, are standing opposite to each other on either side of the road, which is 80-meter wide. So BD is the road. So its length is 80 meter. So BD length is 80 meter. From a point between them on the road. So there is a point between them which is E. So from a point between them on the road. So from this point, the angle of elevation of the top of the poles. So top of the poles are A and C. So their angles of elevation are 60° and 30°. So this makes 60° and 30°. Okay, these are the things given. We have to find the height of the poles. We have to find out AB and CD and the distance of the point from the poles. Distance of the point. Where is the point? Point is here. So we have to find out BE as well as ED. Okay, children? We have to find out those things. Now what we know only this BD value. So BD is 80 meter. So any one value will be 80 minus something. So BD equal to 80 meter. So let me keep BC as such. Let me keep BC as such. Then ED is nothing but BD minus BE. What is BD? BD is 80. So 80 minus BE. Okay. So ED is equal to 80 minus BE. Now what we have to find? We have to find out CD. So from the small triangle, so small triangle 60 degree opposite is CD and angle D makes 90 degree. 90 degree opposite is hypotenuse and this is the adjacent side. What we know? We have to find out the opposite side. We know some values in adjacent side. That is between opposite and adjacent. So opposite and adjacent means we have to use tan relationship. So what are all given? AB and CD are the poles and they are equal heights. So AB is equal to CD and this is between the roads. Road width is 80 meter. That means BD is the road. It is equal to 80 meter. From a point between them, so E is a point between, E is a point between BD. From a point between them on the road, the angles of elevation of the top of the poles. So angle of elevation. Angle of elevation from the top of the poles. So angle AEB. Angle AEB equal to 30 degree and angle CED. CED equal to 60 degree. What we need to find? We need to find AB and CD. They are all equal heights. Both AB and CD are equal. So if we find AB or CD, it is enough. Next, we have to find out the distance of the point from the pole. So from the point to the poles, we have to find out the distance. We have to find out BE as well as ED. Okay, so if you find any one BE or ED, we can subtract the value and find out the other value. Okay, children. So let us do that in the next page. So from the previous page, we have assumed those things. We have to find out AB, CD, BE as well as ED. Now we are going to find AB. AB because AB is equal to CD. And if we find BE and if we subtract from 80, we will get ED. So now our problem is to find AB and this BE. Okay. Now from this triangle ABE, we are going to find some relation. So from triangle ABE. So 30 degree. So this is the opposite side and this is B is 90 degree. So 90 degree opposite is hypotenuse and the remaining is adjacent side. In the same way 60, this is the opposite side. So this is opposite. D is 90 degree and 90 degree opposite is hypotenuse and this is adjacent side. Now we are going to find AB or BE or relation between AB and BE. So relation between AB and BE is for opposite and adjacent. So opposite and adjacent matches for tan. So tan, what is the angle? 30 degree. So tan 30 equal to opposite by adjacent. What is tan 30? Tan 30 is 1 by root 3. Opposite side is AB and adjacent side in ABE triangle is BE. So AB by BE. So just cross multiply. So 1 into BE is B. B is equal to root 3 into AB or AB root 3. So this is one relation. Already one relation is AB is equal to CD and ED is nothing but BD minus D. So BD is 80. So 80 minus B. So this is the second relation. And we have another relation 3. That is B is equal to AB root 3. Now take another triangle CED. So from triangle CDE. Here also we have to find out the relation here. What we have to find out? We have to find out ED as well as CD. So the relation is between opposite side and adjacent side. So we will make it for tan. So tan, what is the angle? 60. So tan 60 degree equal to opposite by adjacent. So what is tan 60? Tan 60 is root 3. So root 3 is equal to opposite side is CD divided by adjacent side is ED. So root 3 equal to, instead of CD, we can write AB because AB and CD are equal heights. So AB is equal to CD. So instead of CD, I am writing AB. Instead of ED, we can write 80 minus B. So these are all from 1 and 2. So just cross multiply. 1 into AB is AB. So AB is equal to root 3 into 80 minus BE. So root 3 into 80 minus B. What is BE? BE is nothing but AB root 3. So now I am going to substitute, instead of BE, AB root 3. So AB is equal to root 3 into 80 minus, what is BE? AB root 3. Now multiply with root 3. So AB will be equal to 80 into root 3 minus AB is here. Root 3 into root 3 is 3. So AB into 3. So AB, this is nothing but 3AB. So minus 3AB will become plus 3AB equal to 80 root 3. That means AB plus 3AB is 4AB. So 4AB is equal to 80 root 3. AB is equal to 80 root 3 divided by 4. 4 is in product, so it will come to division. So 1 fours are 4, 2 fours are 8 and 0. So which is equal to 20 root 3 meter. That means AB is equal to 20 root 3 meter. I hope you can understand up to this. Let me again explain. From triangle ABE, we got one relation, and from triangle CDE, we got one relation. So instead of BE, we are substituting AB root 3. So this is from 3. And we got AB value. So AB is equal to 20 root 3. What is AB? AB is nothing but the height of the pole. Now we have to find out BE and ED. So if we find BE, then we can easily find out ED. How to find BE? So BE is nothing but AB root 3. So AB is 20 root 3. So substitute AB is equal to 20 root 3 in 3. If we substitute, then BE will be equal to, instead of AB, we have to substitute 20 root 3. Already there is one 3. So 20 into 3. So 20 into 3 is 60. So B is equal to 60. Then what will be ED? ED is nothing but 80 minus B. I will do it here. ED is equal to 80 minus BE. So 80 minus, what is BE? BE is 60. So 80 minus 60 is 20 meter. So 60 meter, 20 meter, that means height of the pole equal to 20 root 3. So AB is nothing but height of the pole. So height of the pole equal to 20 root 3 meter. Next, distance of the point between the poles. So distance of the point from the poles. That means the distance is BE and ED. So B is equal to 60 meter and ED is equal to 20 meter. So these are the values we need to find, and its solution is found out. Okay, children? I hope you can understand all the problems. If you have any doubts, you can comment me. Also, if you like the video, just share among your friends and hit like and subscribe to my channel. Thank you. Thank you for your support.